This is part 2 of the chapter 5 day 2 notes. So we did a few examples previously. So we're going to look again, at evaluating that definite integral. So when you have an integral from b to a, and again, the letters that we use here are irrelevant. But if we have the integral from b to a of f of x dx, this basically is read as the integral of f of x dx evaluated at a minus the integral of f of x dx evaluated at b. This is what's referred to as the first fundamental theorem of calculus. And it says if f of x is a continuous function on the closed interval from a to b, and the antiderivative of f, so capital F of x is any antiderivative of f of x, then the integral from a to b of f of x dx is equal to the antiderivative of f of b minus the antiderivative of f of a. Again, what's important is that whatever the upper limit of integration is, that goes first, and then you're subtracting the lower limit of integration. So we're going to go ahead and take a look at a few more examples below. The first one, example 3, is we're going to evaluate the integral from 0 to 2 of 3x squared minus 4x minus 2 with respect to x. The first thing we're going to do is take the integral. Now, there is a sum and difference rule for integration, so we can go ahead and take the integral using those. The integral of 3x squared is simply x cubed. The integral of negative 4x, you're going to take and raise the power to 2, and then we're going to multiply 4 by the reciprocal of 2, which is 1/2, so that becomes 2x squared minus 2x. And then because this is a definite integral, we're not going to put plus c, we're going to evaluate from 0 to 2. What that looks like, we're going to evaluate the upper limit first. So 2 cubed minus 2 times 2 squared minus 2 times 2. That's all the antiderivative at 2. And then we're going to subtract the antiderivative at 0, which I'm going to write it out so you guys can see it, but it's 0 cubed minus 2 times 0 squared minus 2 times 0. That whole thing simply becomes 0. As we look at this, 2 cubed is 8 minus 2 squared is 4 times 2 is 8. Those will cancel. You've got negative 2 times 2, which gives us negative 4, and then minus 0. And when we simplify that together, we simply get negative 4. So that integral is negative 4. Now, a question you want to ask yourself is, why is it negative? So why negative? Think about that and try to answer that question. And the answer to that question is the area, or most of the area, is below the x-axis. All right. If we were to go and take a look on the graph of what we were just finding, we were evaluating the integral from 0 to 2. So the integral from 0 to 2, let me try to, as you look at this, you've got 0 over here. So that doesn't quite take you all the way to 2. You have to include this piece over here, and you notice that most of the area is below the x-axis, some is above. But because there's more below than there is above, that's why we end up with that negative answer. So sometimes you're going to be asked a question, why is it negative, or explain your reasoning. You want to be careful not to say because the area is below the x-axis. You want to say, in this case, because most of the area or more of the area is below the x-axis. All right. Most of the area is below the x-axis. Now, if all of the area was below the x-axis, you would be okay saying because the area is below the x-axis. But when it's a combination of some below, some above, you want to make sure you specify, that difference. All right. Guys, we're going to take a look at number 4. I would encourage you to pause the video and give it a shot on your own. Now, if we take a look here, we want to evaluate the integral from 0 to pi of sine of x. So the first thing that we are going to do is take the integral of sine of x. And in this case, the integral for sine of x is going to be negative cosine of x. And we want to evaluate from 0 to pi. So you can handle the next part a couple different ways. Some people like to just take out the negative, which is what I'm going to do in this case. So we have cosine of pi minus cosine of 0. You got that negative out in front. Now, cosine of pi, you got to think about the unit circle. Cosine of pi is negative 1 minus cosine of 0 is positive 1. So you end up with negative 2, which simplifies to positive 2. So the integral from 0 to pi of sine of x is 2. And for a graphical representation of what we just did, is 0 is here. Pi would be right here where it crosses the x-axis again. And what we just found is we found the area between the curve and the x-axis between those 2 points. That's what we calculated when we took the integral. Let's go ahead and take a look at the next example. So for the next example here, we have the integral from 2 to 6 of 4x times root x. Now, again, we've got a product here. So we don't have a product rule when we're dealing with integration. What you want to do is rewrite this integral first. So we have the integral from 2 to 6 of 4x times root x is the same as x to the 1/2. And then that's all with respect to x, which that then allows you to rewrite this as the integral from 2 to 6 of 4x to the 3/2 dx. Now, from here, one thing that I would encourage you to do with integration is if there's a constant in front, take it out. So we want to make that expression we're taking the integral of as simple as possible. So we can take that 4 out and just put it in front. And then as we take the integral of x to the 3/2, what we're going to do is we're going to increase the power by 1, so this becomes x to the 5/2. We are going to multiply by the reciprocal, which is 2/5. Now you still have that 4 in front that you were multiplying by. It didn't go anywhere. And now we have to evaluate from 2 to 6. So you can take that constant out to just help with some of the simplification. As you then go to evaluate this, we can multiply the 4 and the 2/5 to get 8/5. And then here we're going to have 6 to the 5/2 minus 2 to the 5/2. Now, as you go through and you want to start simplifying this, it's not obvious necessarily what's going on, but if I have 6 to the 5/2, I'm basically taking the square root of 6 to the 5th. So there are 5 6's, and I'm square rooting that. So I can take out 2 6's, which is 36, and leave a 6. And then over here, it's that same idea. We're taking 2 to the 5/2. So there's 5 2's, and then we're square rooting it. So we take out 2 2's and leave a 2, which gives me 4 root 2. Now, at that point, you could leave it like that, or you could plug it into your calculator. And when you do, you'd get 132.040. So not the easiest calculation, but definitely something that we can do. And again, what we were doing in that situation is we were finding the area under the curve, between the curve and the x-axis from 2 to 6. And 6 goes way up here, so you can't even really see it all, but that's the area that we're finding when we take the integral. Now I'm going to show you quickly how to do this problem using a calculator, because that is a tool that you guys will have available to you. So if you open up your calculator, we can go menu, as we want to make sure that we're either in the scratch pad or we're in a document, but we want to go menu, we can go calculus, and number 3 is integral. So we're going to go ahead and take the integral from 2 to 6, and then we can just type in the original problem. So we have 4 times x, and we're going to multiply that, we're going to multiply that by the square root of x, and we're going to integrate with respect to x. And if we hit enter, we'll get our answer. You know, as you look, that's the exact answer in a simplified form. We should be able to hit control enter and get that decimal approximation, which you might remember I said was 132.040, which is what that would round to. So just a reminder, with College Board, any answers involving decimals need to go to 3 decimal places. It can either be truncated, which means you just cut it off, or you round to 3 decimal places. So this truncated would be 132.039. When I wrote the answer before, I rounded it because the 6 makes the 9 a 10, so that's how we got the 40. But just remember, you always want to make sure with decimals you go to 3 decimal places for College Board.